So what we're going to do next is pick a point perspective. But before this, I want to illustrate what happens if this enclosure is closer to the camera or further away. And to do so, where when I get closer, I zoom out. So it's basically the same size. And when I pull it away, I zoom in. So again, it's taking the same size in the screen. So you can see what happens when our perspective changes. The physical size of this in the screen will be roughly the same, but what parts of it you can see and your perspective on it will change. So let's see that. So you can see here I have zoomed way in and you can barely see kind of the inside of the frame right here. And I'm going to move it much closer and I'm going to zoom out. But now that I'm much closer, I mean, look right here, you can see way more of the inside. Look at the bottom, you can see way more of the internal edge of this frame. Okay, let's try that again. So we'll zoom out. Again, up here, you see how you can't even really see the internal side, and down there also as well over here you can just see a little bit of it, but as I bring it closer and zoom out, even though it's the same physical size, look at how much more of the bottom edge I can see, or that edge, sorry, I'm trying to point in the right direction. You can see much more of the inside. Okay, there's many different angles in which you can look at an object. You can look at it a bunch of different ways in three-dimensional space, but to make things simple, we're only going to really look at two. So we'll start with, what if I'm looking at dead center? I have an object like this, I'm looking dead center, I have a perspective here. So you can see drawn on the screen here is I've got this shape, looking at it this way with the depth of the inside here drawn. And so here's basically where my perspective point is. It's where I'm looking from. It's where my eye is. Okay, and I'm looking in to the inside, and what I've drawn here in red lines is my line of sight to the inside of this shape. And what I want you to see here is that this section of the triangle right here, that section of the triangle actually gives you a sense of how big the deeper part looks in comparison. Do you see how this part that I just outlined in green, and I'll try to fill that in, it's like a dark green now, is shorter in distance than the actual back of this thing, the actual sort of yellowish brown right there. This is longer, but what I see, because it's further back away from me, it's further in, the perspective that I have is what I actually see on this green line. And so then how do I actually tell how long it looks? I know how long it is, I measured it, but how long does it look? It's further away, it looks shorter. And so all I need to do is remember some things about similar triangles. And one of those things was, if you have a triangle, any triangle, does not matter, and you take one side and you draw a parallel line. So say this red line is parallel to the bottom of that triangle. What you've just done is you've created two similar triangles. You have that top one, and then you have the larger one. And they're similar, which means that they're in proportion. So what I want to do actually is go over here in this shape, and I want to know how far away am I from the object. Okay. Now here's where you get to just pick. This is not a fixed thing. You're deciding what perspective. The farther away you look, the more it's going to look like that orthographic perspective where you can't see the inside. If I take this object and my eyes real close to it, I can easily see the top and bottom and sides of this object. But if I'm, and I'll have to hold it off screen, but if I'm way far away, get as far as I can, I see less of that edge because my perspective can't see inside the box or inside the case as well. So just like that here, I need to choose a distance. Now, for the sake of drawing it, the shorter the distance, the actual easier it's going to be to draw a perspective, because then you don't end up with these super tiny, thin distances. So what I'm going to do is I'm going to pick a distance of looking at it from 6 inches away, which is really close. So I'm going to write in here that this is 6 inches. From our previous work, we know that the depth of this is just 1 inch. And here's how the math comes in. And once you understand it, it's not hard to actually use this on pretty complex problems. So here's the deal. How far is the backside away from my perspective point? Well, I have to add 6 inches plus 1 inch is I am now 7 inches away from what I'm looking at. Well, how far away in that same direction is the actual front of the object? Well, that's only 6 inches. The front is 6 inches away, but the back is 7 inches away. So the back looks smaller by a ratio of 6/7. And so when you multiply 6/7 by dimension back here, which if we look, it says right here that that dimension is 4 1/4. So I'm going to multiply it by 4.25, which is 4 1/4. And I can go ahead and use my calculator to do that. And I will figure out what the actual perceived length is. So let me do that right now. Which is 3.64 inches. And so there you have it. This backside here, it is 4 1/4 inches, but based on me looking at it from 6 inches away, it looks as if it was only 3.64 inches. It looks smaller because it's further away than this front side. And by how much? Well, by a factor of 6/7. The front side is 6 inches away, but the back side, this inside here, is 7 inches away. So it actually looks 6/7 smaller than my actual measurement in comparison to that front edge. The last video I'll put out next week, which will show you how to draw this object to scale using the information that you've calculated using similar triangles.